In the last video, I got all about the Netcat for port scanning specifically, and in this video, I'm gonna deep down into map scanning. I'm gonna cover everything you need literally for host discovery. First of all, we'll understand how host discovery actually work at the TCP IP layer. We're gonna talk about the ARP, ICMP, TCP, and UDP, and I'm gonna explain why each of these methods exists, and I will also talk about what happens when firewall blocks them. Second of all, I will be talking about the all of the flag for host discovery, and third, I'm gonna talk about the ping sweep and how to read the result. And finally, I will talk about the different type of output format, and I will also talk about the grab tool and cut tool, how we can get a specific result, specific section of a Nmap result, Nmap report, right? So without any further delay, let's get started. Okay, before we do anything, I'm gonna explain why host discovery exists in the first place. It's very important to understand. For example, you have been given a range of IP addresses, and they want you to find out the ports, open ports on all of the devices that are alive. So you have two ways. One, you just directly scan all of the IP addresses they have given you, and the Nmap will literally scan all of the top 1000 port for all of the devices, even if they are offline or online. The Nmap will just scan for all of the IP addresses, and it will take some time, And another important point is that not all of the IPs, all of the hosts will be up. There will be a lot of the IP addresses where the host will be down. So if you run Nmap scan directly without checking or finding out which host is alive and which host is not alive, you will be spending a lot of time on waiting. Because Nmap will be doing the port scanning on all of the devices. Now, the better approach is that first of all, find out the host devices on the IP ranges you have been given, which will help you to find out only the IP addresses where the host is alive. Once you have all of the IP addresses, like let's say you have 100 IP, and out of that 100 IP, there are actually 4 IP where the host is up. Now, which approach will be better? Port scanning all of the 100 IP or those 4 IP where the devices is alive? Obviously, the second one, because it will save time and it is a better approach. So when you find out the 4 devices that are up, for example, what you're gonna do is you will then move into the port scanning. Now what will happen is that the Nmap will again literally scan the top 1000 ports depending on your scan type, right? So it will then look for the 1000 port for one device, then 1000 for another, then 1000 for another, then 1000. Total it will become like 4000 port. So it is much better than checking out the ports for all of the IP addresses, even they are not alive. So this is why the host discovery exists. It helps us to find out the host address, and then kind of saves our time. Let's talk about the Nmap. Nmap is a network mapping tool. You already know we use it not only for port scanning, but there is a lot of stuff it can do. For example, it can find out, it can do the like host discovery. It can do the host discovery. It can do the port scanning. It can also do the service detection, as well as it can find out the operating system fingerprint, like getting information about the operating system that is running in the target machine. And it also can run very advanced script, which is called the NSE, Nmap scripting engine, right? For now, I'm gonna just start with the basic, not just directly getting into the NSE or operating system fingerprinting or service detection. I will be explaining these in the next video with much better approach and in detail. So for now, let's talk about the host discovery and like the scan type, how we can find out which horse is up, which horse is not up, and different methods of that, right? So over here, this is how you can install the Nmap. If you want to check if the Nmap is already installed, what you will have to do is just open your terminal and type which nmap, and it will show you the full path of the nmap. Now once you figure out you have actually the nmap installed, what you will have to do, the next step you will have to take is, if you don't know, if you are new to the nmap, you will have to type the nmap -h. It will just tell you the short summary and tell you the flags, the option and its syntax. And if you want the full manual of the nmap, you can just type the main and the nmap over here. When you type the main nmap, the manual page is way too long, but thankfully they have organized it, and it will you will be able to see it like this. For host discovery, like kind of in categories in section. So for host discovery, you will see all of the flag that is related to it. Then for scanning technique, you will see all of the flags related to scanning technique. Same is the case for port scanning, service detection, operating system detection, output and timing performance related stuff as well. The basic structure of all of the command will be, first of all, you will have to type the nmap, then the scan type or the flag, whatever you want to go with, right? And then the option, and then you will have to specify the target, either a single target or multiple target, right? So that is the structure of the basic command. Now here's another thing, how actually host discovery happens in the TCP IP layer. So let's say in layer 2, we are on layer 2, we are connected to the same network. So what will happen actually is that it will uses the R packet address resolution protocol, and since you are on the same network, the R packet won't be blocked by the firewall. It will be blocked if the packets were coming from somewhere else to our network, but since we are on the same network, so it will use R packets. And the problem with our packet is it is not routable. It cannot reach to other devices on other network. So it is for local network. Then we have the on layer 3. It uses ICMP packets, right, called the internet control message protocol. They are routable, they can go to other devices on other network, but the problem with this is since it's going to another network, and that another network might have the firewall, so it can be blocked, right? Same is the case for the layer 4 over here, transport layer. It uses the protocol TCP and UDP. It can also be blocked because it is again going to another network, a device that is on another network. A firewall rule might block them, right? So that is a broad overview of how host discovery happens at the TCP IP layer. Next, here's some more important stuff over here before we start host discovery using the different types of flags. If you want to specify a single IP address, you can just type the SN. I'm going to explain what -SN mean in a moment, but nmap -SN, this is a single IP, means you are targeting a single target. You are specifying a single target. CIDR notation means this is a range of networks, like there will be 256 IPs. This is some related to networking. This is a networking concept, and this right here is not a networking class, so I'm not going to explain this over here. Then we have the same IP, we are specifying another range, a CIDR notation. And this is we can specify the ranges of IP like this as well, from start from 1 till the 253, or we can do it like this as well, specify specific amount of IP, or we can specify different targets at the same time by just typing the IP addresses with a space. Okay, and if you have multiple IP addresses, lots of IP addresses you want to scan, the best approach is put it in file all of the IP, and then use the -il to feed it to the nmap, and nmap will look to that file exactly and look for all of the IP and do its scanning on each of it. Right now, let's talk about the host discovery using the UDP and TCP. There's a lot of difference, and we will be talking about the important ones. Remember, I told you at the start of video why host discovery is so important. If let's say we somehow miss one host discovery, let's say we for some reason we miss out any device that is on a network, and it is running any service that can be exploited, and for some reason we forget or we miss that device that which is alive because of firewall role or for some other issue, we can leave a very easy exploit on a table. So we need to be better with host discovery first of all, and then if we don't do the host discovery better, it will be hard. We might miss some devices, and because of that we will move into the port scanning section, and we will be doing port scanning on the devices that might not have the vulnerable servers. So yeah, that is important to note, that is important to understand. So we have the -ps option over here. When you use the -ps option, what gonna happen is that first of all the default port for this is port 80. Okay, there's some specific reason behind this, but yeah, uh this is the flag, and what it couldn't do is basically it sent the sync packet to the target machine, to the port 80. If you don't specify any port, it will send it to the port 80 or on the target machine. And if the port 80 is open over there on the target machine, it will send us acknowledge packet, okay, to our machine, to the Nmap. And once Nmap receive that, Nmap will think, yeah, I have got the acknowledge packet, meaning the port is open and something is listening on that port 80. Now same is the case for if you specify any other port. You can specify any port like -ps and whatever port you want to specify, or multiple ports as well. It will send the sync packet to all of them, and if all of them any of them is open and listening, it will send back us the acknowledge package. So this is how we can find out if the host is alive or not. Look at this. If the port is open, the target will respond with the sync packet, acknowledging that, yeah, I have got your sync packet. And if the port we will get the acknowledge back, we will get the sync acknowledge. So Nmap will see, yeah, it is open, the port is open. And if the port is closed, the target will respond with the RST packet, meaning reset packet. It's kind of rejecting the connection. The port is closed. So in both of the cases we get a response, and from that response we can say the host is actually alive, right? Now let's move into another scan, which is called the TCP ping. Normally this is something unusual. Normally when you wants to start a connection with another device, what you do is first of all you send the sync packet in the target, send you, if the target is listening and alive, it will send you back the acknowledge packet. So from that you can find out, yeah, this host is either alive or not alive. Now with this scan, what happen is instead of sending the sync packet, it send the acknowledge packet, the middle packet. And once the target receive that, it will see, this is very unusual. So when the target receive that acknowledge packet for connection, the it will think that I have no record for any connection, that I have got the sync packet. So it will send us the RST packet back, and from that we can say, yeah, the host is alive. And the in the modern system, this used to work in the older system, because there were firewall, different types of firewall. One is stateless and another is stateful. The stateless does not care about, like, it's a weaker version of the firewall, and the stateful is a powerful version. It checks the connection state. If there is no already established connection, it just kind of drop the packets, and hence you will not get any reset RST packet, and from that we won't be able to know if the host is alive or no, right? So that is the problem with this specific scanning. Now let's talk about the UDP port scanning, how we can find out the UDP ports with the -pu. The TCP has three-way handshake, so from it makes it very easy for us to figure out if the port is open or no. UDP is something else. It is connectionless protocol. You already know about this. So what actually happens is when you send a UDP packet to a closed UDP port on an alive host, right? The target kernel will respond with a specific type of ICMP packet called the type 3, and the message it will give us is the destination is unreachable, and that error that we get, the destination unreachable, the ICMP error message is how Nmap knows that the host is alive, not from actually the UDP response, but from the ICMP error triggered by the clause for a UDP port, right? So I'm just gonna go to the curl Linux and find out if the UDP port, what are the UDP ports open and what response we get. So over here you can see that, and I'm gonna type this. So we have the Nmap and the PU, which enables the UDP mode, and SN I'm gonna explain, which is related to sweep ping. We call it sweep ping, and this is our target IP, and we are specifying the full range of all of the IP, meaning it will scan the 256 IPs. Okay, so I will just started the scan and let's wait for it. So before we wait for the result, the scan to get completed, let's talk about the another type of scan, the -SN. It is called the ping sweep, and it basically means skip the port scanning and just find out if the host is alive or no. So when you don't use the SN flag, what happens is that Nmap discovers the live host and then automatically start the port scanning. And if you want to just do the host discovery, you will have to specify the -SN. Over here you can see the without the -SN, this finds live host and automatically start port scanning them. And if you use the -SN, it means it just only finds out the devices, the hosts that are up, and then skip the port scanning. So that's the main point of this -SN. And just to get a bit more theoretically in a bit more detail, when you use -SN, it basically sends different types of packet to the target machine to figure it out whether that is alive or not. The reason it sends different packets is that there might be some firewall that might block one of these or more of these, two or three of these packets. The firewall might keep it down these packet, and might one of them go through the firewall and actually give us the response back that yeah, the host is actually alive. I have just checked the scan, it was completed, but we did not get any result, any report, because I think I might have mentioned the wrong IP of the target. But the thing is that it will most probably give you back the error message that the destination is unreachable, and from that we can say that yeah, the host might be alive, right? The next important thing we need to mention and talk about is that output formats. When you run the Nmap scan, whatever type of scan, doesn't matter, but when you do that, you have to save that result in order to use it again, reuse it again. So let's talk about the different type of output formats that we can get the result from the Nmap. First of all, we have the normal output, which we can specify with the flag hyphen -on. And what this gonna do is it will basically save the result in a file as it is, as we see on the terminal on the screen. So let's say we run this the whatever scan, and we specify the -on, and in some file we store that result. So what it's gonna do is the Nmap will save exactly the same in the same format as it shows on the screen like this. So this literally contains every single detail that we got from the Nmap scan. The another type of output is the -og, means a grippable output. This grippable output format does is it basically set each of the hosts that we discover into a single separate line, so that when we are using the grep or the git tool to just only get the specific line or specific host, we can just specify the line, and we can just specify the specific line, and we will then get the result. That is why it is called the grippable output. For example, we just start the Nmap scan and store the result in this. Okay, and when we carried out this result, it will look like this: the host and the host IP, and then the state of the device, whether it's up or no. So you see right here, it is divided. Each of the hosts that we figure out is kind of in a separate line, and we can use grabs or other tool to get a specific result we want. So we can use tool like grab or cut and specify the line that we are interested in. For example, the line to and we will get this line, we will get this specific line in our output. And the third type of output format is the XML format, or also you will have to specify this, and it will kind of give you save result in this kind of format. You can see right here. And if you want to save the result in all of those three formats, what you can do, just type simply the hyphen OA, and it will basically save the result in all of the three type of format that we have just talked about. And it is a better approach. Let's say later on you need some specific type of the out of these, any specific type of the output format, it will, all of them will be there and you can just use them. So it's better to use the hyphen o, and you will get all of these. Example over here is that you start nmap on this specific port, and you use the hyphen o, and then discovery sweep, whatever you specify the file name. It will basically create three different files. One is the nmap, another is gnmap grippable format, and then another is the xml format. So that's pretty much it with the formats. I'm gonna just quickly tell you how you can use the grep tool and the cut to get a specific result from this grabbable output. So over here we have this specific let's say the basic pattern. First of all is grep and the pattern and the file name. So we'll use grep, and then the pattern we want to search for or get the result from the file is, let's say we are specifying the word up, and we will specify the file name. So it will give us the result back of all of the hosts that is basically up. To use the GERT tool we have two different options. One is the -d and -m. The -d is a delimiter. It means what separates the field, and the -m is the field number. For example, this is field 1, this is field 2, this is field 3, and this is field 4, and this is field 5, I guess. So yeah, we have to specify this. For example, what we're going to do is we want to specify, we want to get the IP address of the up of the device that is up. So what we will do is we'll use the GERT, then we will use the -d with a space in quotes, and then -f we will specify the field number, which in this case is the second IP. Since we want the IP addresses, we will specify the 2. Okay, so what we're going to do is we'll use the grep to find out the up devices that is alive from the result we got that we save in this specific file. And next we will use the grep again, and we will use the pipe, and then we will use the GERT, and we will specify that we only need a specific field. So what it will do is it will kind of give us the result like this, a clean result, only the IP addresses that is alive. Okay, so that is how the output format and using the GERT and grep works. So I hope you understood all of the stuff that I have explained. If you have any question in any of these, let me know. And in the next video we will be basically starting the port scanning. This was just theory how to find out the host discovery. So in next video we will do the port scanning. So I will see you in the next video. See you soon.